Hello, this is John Baker with another NX Quick Tip video. Today we're going to talk about a couple of enhancements that we've added in NX 11 that deals with the creation of defining holes and adding the dimensions, drafting in a drawing for those holes. So in this case I just have a simple part. I'm going to start by creating a hole, in this case a threaded hole, and I'm just going to simply place that on the face here. And now we see a preview of the hole. Now what we've changed in NX 11 is, in the past the only way to define the depth of a hole that wasn't a through hole was to define what we call the cylinder height, which is this height here. Now that's actually a very critical height, because that's what the manufacturing people use when you would ask to manufacture this hole. And the reason they're asking for this information, even though the hole goes a little deeper because of the drill tip, the tip point down here, this is really the only dimension that they can accurately measure after they've completed the hole. So in order to verify that you got the hole that you expected, this is what you give to the manufacturing engineers, is the size of the hole and the depth of the sidewall. But as designers, sometimes it's very important for us to know where the actual end of the hole is, because it might be part of a manifold or something where it's confined to a very small area, and you don't want that drill tip to break through the model. So you would really like to control the depth of the hole based on that tip length. But we've never given you that ability in the past. You'd have to work it out for yourself. Basically, calc it out, trig it out, as we say, with the 118-degree cone angle here. You'd have to figure out what extra length was involved here, and to compensate, because you'd have to then change the value of the height, the cylinder height, in order to get the tip point to be where you wanted it. Well, now we have an option here. Now you can either do a cylinder bottom, which is the traditional way, or you can do by cone tip. So when I say 32 millimeters now it's 32 millimeters from the top of the hole to the end of the tip, not 32 millimeters down the side. If I change it back to cylinder height, you can see where this is now 32 millimeters, and the end tip will be whatever it is, but I'm only specifying this. So this is kind of a new way of defining the depth of what we call blind holes, or holes that are not through holes, so that you have the option now of controlling the depth of the hole either by the sidewall or the tip. Now, irrespective of which method you use, when you go to drafting and document these holes, it's going to be documented in such a way as to what information we need to give to manufacturing. So even if you specify the tip depth here, the cone tip, the actual symbols and dimensions on the drawing will still be for the sidewall, because remember, that's the only thing manufacturing can reliably use to manufacture the hole and to assure you, the designer, that you've got the hole that you specified. So changing the method of defining it doesn't change the information we give to the manufacturing engineer. Now, speaking of that drawing, let's go and take a look at our drawing here of this very simple part. And of course, people know that if I go in here and I want to create a symbol, I can come in here and say, well, here's my hole symbol, and I have the option of adding additional information like the thread depth and the depth of the hole included here. So now my symbol includes not only the size of the hole, of the thread, but the depth of the thread and the depth of the hole. And so we'll just locate it there, and there's my symbol. Now, in the past, people say, well, okay, this is a way of creating a symbol, but people didn't realize that you could also create a symbol with the side view here. So I'm going to create that same whole call out, only I'm going to use what we call a linear method. So here is that similar symbol, and if I come down here and add the thread depth, I would get something very similar to what I had before, except it's in a linear format. However, if I'm doing linear dimensions, why would I want to do it this way? What I could do now, I have an option of actually going ahead and creating all the linear dimensions automatically. So Now when I create this, I've created the call out up here for the size of the hole, but I've automatically created the thread depth and the hole depth dimensions automatically. Now this is not one big symbol. Even though I created it using a single command, I've actually got here is 3 separate dimensions which are editable, individually. But what it's done is it's created all 3 pieces of information in one operation in a format that may be more suitable for the type of work that you do. Of course, you could still use a single call out, similar to what we have up here, or if you prefer to do it in a linear fashion, you can now have the linear dimensions defining the depth of the thread, the depth of the hole, and the size of the hole. What's new for NX11 is this ability to automatically create these extra linear dimensions. Previous to NX11, you could create the symbol, either this symbol as shown here, or a similar symbol but in a linear format in a view like this. In NX11, we added the option of saying, no, I only want to use just the size in the symbol, and the rest of it I want to include as actual linear dimensions. So those 2 projects are not really related to each other directly, the ability to define the hole differently, but again it shows that we're working on even some of the small detail areas, like giving users the ability to define and to dimension details like holes in a fashion that's much more suitable for either their type of work or the issues that they need to be concerned with as they create their models and as they document those designs for manufacturing. Thank you very much.